Hey! Didn't see you there. You're interested in learning about Docker and why we use it and how to use it?
Yes, but actually no.
Well, great, you've come to the right place. Let's talk about that. But before we can get too into what is Docker, we have to understand the problems that existed before Docker existed and why Docker was created and how it solves those problems and how it sometimes doesn't solve those problems. So to do this, let us go back in time to a simpler era where you had the great and mighty application. But this application doesn't exist alone. No application does. It sits on a number of binaries and libraries that it interacts with. You're like your OpenGL or whatever it might be that your application depends on. And in turn, those binaries and libraries sit on top of a kernel. And this is the translation layer. This is, the operating system of how those binaries and libraries then interact with the hardware. That kernel is that wonderful translation layer. And all was wonderful and good. Except there are a few major problems with this type of deployment. Importantly, you'll notice that we're not necessarily using all of the resources on this machine. And this can be really cost ineffective, especially given how expensive computers can be, and especially were back in the day. So how did we go about solving that? Well, the first solution was to simply put more applications on it.
Duh!
So here we have application 1 and application 2, both sitting on the same binaries and libs, sitting on top of that kernel, and sitting on top of that hardware. And everything is great. We're not wasting extra money. But now we have a different problem. And that problem is, say application 1 uses Java 7, and application 2 uses Java 11. Now, those binaries and libs, they can only have one installed, or you can have multiple installed, but it gets pretty complicated. And in turn, this kind of leads to this dependency issue where, oh hey, you got two separate applications completely separate from each other with two completely separate lists of their dependencies, and it can be really difficult to get them both working and running nice and stably on the same hardware. So the clever lads back then came up with a wonderful solution, and that solution was virtual machines. Now, virtual machines are fantastic, and we still use them today. And the way that they worked is your application, instead of sitting on the same binaries and libs, they would have their separate binaries and libs, and then you'd have a virtual kernel, and that virtual kernel would sit on top of another application called a hypervisor. And a hypervisor pretty much pretends that it's physical hardware, so that kernel thinks that it's talking to hardware, but in actuality it's just like a nice happy translation layer. And this hypervisor, of course, is an application sitting on top of a machine, so it still has those bins and libs and that kernel and this other hardware. Now, this is fantastic because now when application 1 is reaching out and needs to have certain version requirements, and application 2 is reaching out and has its own requirements for its dependencies, now there isn't going to be any sort of collisions. So, fantastic.
This is brilliant.
But there's a different problem that we've yet again introduced.
Why are you the way that you are?
And that problem is, oh hey, we've got to virtualize an entire kernel, and that's not a cheap operation. So we're spending a lot of time doing this, kind of expensive virtualization. And it's especially strange since we actually already have a kernel. Not to mention the fact that when you're dealing with virtual machines, you got to start up the virtual machine from scratch. So if anyone has experience starting up a computer, looking at you, Windows 10, it's not necessarily the most speedy thing, especially when you consider usually if your computer's already running, that application is going to start up near instantaneously. So while virtual machines are very helpful and were a leap forward and are still useful in many applications, they still had some pretty large problems that kind of hindered their usability in many cases. So this is where containerization and Docker comes into play. What Docker is rather than virtualizing the entire kernel, what it does is it packages up your application with the binaries and libs that your application needs, and it sits it directly on top of that kernel. Now, you will note there are a few important distinctions to make. Because both of your applications and both of your binaries and libraries are sitting on top of that same kernel, that kernel has to work for both of them. And kernels are usually operating system specific, which means that you can't run a Windows application and a Linux application at the same time because they need separate kernels.
What?
And all of the applications running on your machine need to use the same type. And luckily for us, that is pretty much always Linux, because hopefully you don't hate yourself enough to use Windows Server. Eeh.
Why must you hurt me in this way?
So now that we understand why you might want to use Docker, let's take a look at how you might use Docker. And I like to break this up into the 3 main concepts of Docker. Ooh, that'd be a great clickbait subtitle or whatever on the, yeah, this is what it is. So the first concept of Docker is going to be your Docker file. So this is the instructions of how to build your image. So that image that you have that contains your application and your binaries and libs, these are the instructions to go from nothing to having all of that stuff installed. And then we have the second concept, which is a Docker image. So after you follow all of those steps, the resulting thing that you'll have is a Docker image. And this is a packaged version of your, all of the dependencies that you need and your application. And then lastly, we have a container. And a container is a running instance of your image. So you have your Docker file, you use that to build your Docker image, and then you use that to run your Docker container. And now you have the Docker container running and doing its wonderful Docker things. Okay.
Oh, yeah.
Alrighty, let's deep dive on some of these topics in particular. For example, let's take a closer look at the Docker file. So a Docker file consists of mostly 3 parts. I got like this 3 thing going, and I don't know, it works, don't worry about it. And so what this might look like is what you're seeing here. And this is actually a completely valid Docker file, what you're seeing. But I want to kind of split up these different sections. So the first section is going to be your from. And this from is going to start from another image, usually. Because usually you don't want to start from complete scratch. And so someone out there has already developed a Ubuntu image. And this is just all the binaries and libraries that you'd usually expect on an Ubuntu machine. And it's been packaged up and it's nice. So if your application runs on Ubuntu, it'll probably run on the Docker Ubuntu image. And there are also other images for pretty much anything. And if you really want to, you can start from scratch. But if you do that, you'll have just a completely empty image. Like we're talking no command line interface, no shell, like nothing. Like it's pretty bare bones, let me tell you.
Don't even think about it.
So after you've decided which image you want to start with, now we have to do the setup steps. So this is pretty much the steps that it takes to go from the image you started from to your application being installed and ready to run. And so in this case, you can see we're usually like installing the dependencies, and we're also copying in whatever your application might be. So in this case, my application just consists of a quick myscript.sh, so I'm copying that in. And then lastly, we have the start command. And so this is a special command that says, when the actual container starts, this is the process that I want to kick off. So this is my actual application. So in this case, when the application starts, I'm going to run bash and then my script. So it's going to run my script with bash. Awesome, great. That's a Docker file for you. It's great. Whatever. One last real quick thing. In order to take this and build this and turn it into a Docker image, which is what we're going to talk about in a second, we use Docker build. So let's look at what a Docker image is. Now, a Docker image is a little more difficult to visualize using just a text block here, but I did my best. It works. And so a Docker image consists of all of the binaries and dependencies that your application has, as well as some metadata. So for example, we have the metadata that says, oh yeah, this is the startup script. And there is some other metadata, but it's not quite as important.
Are you sure about that?
And so you can kind of think of this as just a big tar file for the most part. It's just all of this stuff packaged up together nicely and ready to start. And then last but not least, we have the actual Docker container. And this is a running process on your machine. And so this is a running process, and it is that script, that is your script, it's your application, just running like it would, except it's being sandboxed to only interact with the binaries and libraries that was a part of the image. So we don't have any external dependencies on the rest of the machine, which is really great. It means that if you have this container, you can run it anywhere, as long as you have that kernel that you can sit on top of, that Linux kernel. Alrighty, now we get to the fun part. Here comes the demo. All of the source code for this demo will be available on my GitHub, so feel free to go stop by. Give it a star while you're at it, whatever. Have a good time. It's fine, it's fine.
I'm good, bro. You geeking, bro.
Alrighty, so I have an application, and this application is a very simple Python web server. Now, obviously, Docker is not dependent on a particular version. It can containerize any sort of application. I just chose Python because I'm a programming noob who only knows how to write Python, or at least am most familiar with Python, so whatever, it's what we're using. Okay, you don't super duper have to understand exactly how this works, and you can probably imagine how this transfers to other languages, but on a high level, this is just a web server that serves up hello world whenever someone makes a request, and it just binds to port 8080. And we can actually run this because I have Python installed on my local machine, and we can give it a go and see what happens. So I'm going to run Python and then app.py. And this is going to start up that web server. And if we jump back over to the browser, we should be able to go over to localhost 8080 right here. And look at that. Hello world. Man, this is great. Let me tell you, I'm a professional web developer. Looks beautiful. Amazing. So this is fantastic, and this is really great, but there's a key problem, which is if I wanted you to be able to run this on your machine, you'd have to go and install Python, you'd have to install all of Python's dependencies, you'd have to get all of your, my dependencies, the libraries I'm using. For example, I'm using Flask. You might not have that installed. You'd have to set up your Python virtual environment, all that kind of stuff. And it could be really time consuming, especially if you just want to be able to run this application. So what we want to do is we want to take this application, and I think you're probably catching along, we're going to put it into a nice Docker container, and then we'll be able to pass that around and be able to run, it'll have a lot of dependencies and all that. So first things first, we need to create that Docker file. So I'm going to just create a new file. I'm going to call it Docker file. And here we go. And we're going to start writing it. So if you remember, the first part of the Docker file is you need to specify the from, which image you want to start from. So in my case, since I'm using Python, I'm just going to do from Python. And I'm going to hopefully spell it correctly. And this image just exists. Again, someone made it. You can go look up on Docker Hub all of the images that you need. But yeah, some guy made it, and it exists and already has Python, and it's sorted out all sort of all the other stuff. I could start from like Ubuntu and then just install Python, but this is easier. Awesome. So now we have Python. Next, what I'm going to do is I'm going to copy over all of my files. So I'm going to copy over dot. And so the copy command, what it does is it copies files from outside of the container to inside of the container. So in this case, I'm copying that app.py and my requirements.txt into the container. Next, I am going to run, and this is during the setup, I need to install all my dependencies. I'm going to run pip install -r requirements.txt. Alrighty, and if you're familiar with Python, this should look pretty straightforward, but this is just Python's way of installing all of the libraries that this application uses. And last but not least, I'm going to define that special entry point that says, hey, when I start this container, where should I start it? And what I'm going to do is going to define my CMD here. And this CMD is going to be run Python and then app.py. So when I start up the container, run Python app.py. And there we go. This is a valid Docker container. And we should be able to use this and run it, and that's what we're about to do. First things first, how do we build this? What we're going to do is we're going to run the command docker build, and then I am going to specify the directory that Docker file lives in. So dot, and while I'm at it, I'm going to do a special thing. I'm going to do -t, which just tags it and makes it so when I build this, the image that I make will have a tag that makes it easier to interact with. And I'm going to call it Aaron N. Brock /hello Docker, just like that. Alrighty, so I'm going to give this a run, and it's going to go through, it's going to pull down the Python image, it's going to run my copy everything in, it's going to run my pip install, and then it's going to specify that the command should be Python my app when it starts up. Wonderful. Look at that. That was so quick. Maybe because I may have printed this before and had already done it. Yeah, we'll see.
You're sus.
Anyway, so now that we have this image built, we can run it. And that is as simple as doing docker run, and then you specify the image that you want to use. So Aaron and Brock / hello docker. Look at that. I will say one quick note. If you need network access, or if you want to open a port to this container, you have to tell Docker that you want to open this port, because by default, you don't have permission to do that because it's kept in that nice sandbox. So the way that you do that is you just do -p and then 8080:8080. And the 8080 on the left right here, that is the port on the machine, and the 8080 on the right, that is the port within the container. So I'm saying run this image and open port 8080. And if we run that, we should see the application kicks off and it's running. And if we switch back to our web browser real quick, just like this, this isn't going to look all that interesting, but I'm going to run this localhost 8080 again, and look at that, it's still there. But this time it's not running inside of, or it's not running with Python, but it's running inside of that container. And to prove that that's in fact what is happening, we can take a look and we can see, hey, look at that, I just got a request inside of that container. And this container, again, contains all of the dependencies. So now, if I want to share this and I want you to be able to run it, I can do a special command, which is docker push, and then I'm going to specify Aaron and Brock / hello docker. And what this is going to do is it's going to push it to the Docker Hub. Aaron and Brock is actually my Docker Hub account. And so then what you'll be able to do on your machine is you'll be able to say docker run -p 8080, open up that port, Aaron and Brock / hello docker. And it'll run it on your machine, and you won't even have to have Python installed. It'll work as long as you have Docker running. So wonderful. Let's jump back to here, and we're going to look at the slides again. Okay. In fact, this is in fact the command right here. So on your machine, if you have Docker installed, I encourage you right now, take some time. Let's do this. Run docker run -p 8080 Aaron and Brock / hello -docker. And it'll pull that image down from the Docker Hub to your machine, and it'll start up that server that exposes that hello world. And if you've got Docker set up properly, that should work. That should be all you need to do. And if you don't, good luck debugging it. Let me know in the comments. Yay! I'll see if I can help.
Oh no, he didn't.
Alrighty, so now we've talked about Docker, we've talked about what it is, or we talked about why it is, I should say, and then we talked about what it is and how to use it. And I believe you are now able to understand this XKCD, because, of course, there's an XKCD for everything. So, this is, well, you can read, I don't know, I'm not going to read it to you.
How dare you!
Alrighty, thank you so much for coming. And I don't know, I feel like I need to do the usual things like comment and subscribe or whatever. It feels very icky.
Do it!
Here's something, actually. Let me tell you something. Let me ask for something that you're not probably used to. Why don't you follow me on LinkedIn? I post memes about Google Cloud. Yeah, here's an example meme. Hopefully it's good.
Oh, he like.
And if that's the type of content you like, yeah, follow me on LinkedIn. That's while we're here. Drop any comments or ideas for future videos that you'd love to see me cover in the comments, and I'll see if I can cover them. Nice. Yeah, thanks so much for watching, and see you next time. Alrighty, everyone who's gone is gone. Come here. I've got a secret. It's not over yet.
But I'm not done yet!
We've talked about how to use Docker and what it is and how I can share it with my friends. But we didn't really talk about how to use it in production, and you totally can, and it's super easy now, especially with some of the managed services like Google Cloud offers. So we're gonna look at Cloud Run real quick. It's gonna be real quick. It's another demo, it's gonna be awesome. And the way that Cloud Run works is you pretty much just give them your container and they handle everything else. You don't have to worry about installing Docker, you don't have to worry about the physical machines. It's all managed by Google. You just give it, your container and say, hey, here, make sure that this runs. And they'll just say, okay, cool, it's running on this IP address and, or this domain name. And then your users will be able to go and reach your application, and you never need to touch a machine. It's pretty awesome. Let me show you how simple it is. Okay, demo 2, Electric Boogaloo. You weren't expecting this, but here it is.
Got him!
Hey. So here, we're in Google Cloud, and this is in Cloud Run. If you want to find Cloud Run, you can just search Cloud Run up here and then press Cloud Run, and it'll take you here. And if you need to get set up with Google Cloud, I'll leave a link in the description that's like, hey, getting started with Google Cloud, and give you like free credits and crap, free trial stuff, and it'll be awesome, don't worry. And so once you get here, if you want to deploy your application to the world, have anyone be able to see it, you can just create a service real quick. And here you go. You got all sorts of configuration options, but the only one we really care about is, hey, let me specify that Aaron and Brock hello Docker image. Bam. And then next. And then I'm just going to say allow all traffic and then allow unauthenticated invocation. So anyone on the internet can request this. And that's it. You just press create. And then you give Google a little while, and they're going to go and spin this up for you, and you'll get a domain name. And now through the magic of whatever. Here we go. Get us up and running. And look at this. We have the application up and running. It deployed. We have this URL. If I click on it, open it in a new tab, bam. Running on some Google hosted thing. And I never even had to install Docker or think about Docker. I mean, I did to build the image, but once I built the image, there you go. It's there, and it'll run, and it's running at Google scale and all that kind of fun stuff. So like, you don't even need to worry about it. It's awesome. Thanks for watching. Hope you liked it. Yeah. See you next time.